It's now my great honour and privilege to introduce the President's invited speaker. And I'm delighted that Professor Jason Warren has agreed to be my invited speaker for the spring meeting of the BNS 2022-23. Oh, completely lost. I'm so sorry. So Professor Warren is Professor of Neurology. And also he is consultant neurologist at the National Hospital for Neurology and Neurosurgery. His research group is based in the Dementia Research Centre at UCL. Now, just as is per norm, just a very brief summary of education and career. So, as we know from your accent, from down under, so Professor Warren trained in the Royal Adelaide Hospital in neurology and then continued that training at the National Hospital in Queen's Square. A PhD in functional imaging of the human auditory system, then followed in the Wellcome Department of Cognitive Neurology in 2005. And I think this is one of the areas of interest that has continued with regard to deafness in Alzheimer's, which is an aspect which you're not talking about today, but something that I hope you come back and tell us more about. Currently, he's working as a Wellcome Senior Clinical Fellow, leading a research group that uses complex sound as a paradigm to understand disordered information processing in neurodegenerative diseases. Special interests include progressive aphasia and using functional imaging more generally in neurodegenerative diseases. Now, as with all academic research, there has to be a wider impact. And if what I've said already isn't sufficient, Professor Warren is a published poet.
That's a generous estimate.
A aficionado of Bach and Schubert, to the extent that you have been invited onto desert island discs.
I have, though not in my own right. It was an unusual episode, but I was happy to go along. Yeah.
And then I think one of the things that touched me really when I was doing my research was that you've published some of your patients' poetry.
Yes, and one of those is in today.
Fabulous. So reflecting the inner life and not just the observation of aphasia. So a very humane approach, I think, which has touched the lives and represents the individuals and their experience of aphasia in its various forms. So thank you very much for coming today, and I look forward to hearing more about the talk, which is a bit of a tongue twister. So, Where the Wild Things Are, a voyage around primary progressive aphasia. Thank you so much.
Thank you very much, Nikki. And it's a great honour, genuine honour to be here, and also more than a little daunting, because I'm very well aware that there are people in the audience who have forgotten more about aphasia than I ever knew. So genuinely daunting. The title, which I was strongly counselled by my research group not to use, is paying homage, as some of you may know, to one of the great books of the world, which is Maurice Sendak's Where the Wild Things Are, which is 60 this year, coincidentally about the same age as many of our patients with primary progressive aphasia, and essentially details the story of Max, the small protagonist, who's one of the great existential heroes, who challenges prevailing dogma, his mum, and gets banished to his room. And from there, he embarks on a voyage to the land of the wild things, which he discovers to be unruly beasts, which he tames through a mixture of magic and cunning, and then ultimately returns home to discover that they're more mysterious than he ever suspected, and also that he hasn't really come very far at all. So putting all of that together, I thought not a bad metaphor for the world of primary progressive aphasia in some ways. And the other reason for using it is because it pays a slight tangential homage to the first day of this meeting, because the book is so powerful for many of us in transporting us immediately back to another time and place, which is much of what we were talking about with Andrew Mays' symposium yesterday. So before I leave the title alone, just to point out slyly in passing, you can think of wired as a sort of an orthographic representation of a misarticulation of wild. So the sort of thing that happens in non-fluent variant primary progressive aphasia. Things is a clear circumlocution of the sort that we see in our semantic patients. And ma is a phonological substitution, which of course is a hallmark of logopenic aphasia. So I thought I'd work them in along the way. Right, so this is, the other reason for using wild things is because it's about fiction, and to some extent, a lot of what we say about primary progressive aphasia is a fiction. And this is the first fictitious slide, which is a relatively simple laying out of the situation with primary progressive aphasia, what you might think of as a bedside algorithm for diagnosis. And you know, if you look at the dogma in the current consensus criteria, you might say, well, if you were looking at someone who comes into your clinic, they've got a speech apraxia, you're going to classify them as having non-fluent variant primary progressive aphasia. If they don't have speech apraxia, we should check that they don't have agrammatism, output agrammatism. And if they do, they probably also have non-fluent primary progressive aphasia. If those things are basically okay, then you move to word comprehension. And if they've got impaired word comprehension, well, they've got semantic variant primary progressive aphasia, aka semantic dementia. And if all of those things are intact, well, you then need to test phrasal repetition, because if phrasal repetition has gone down disproportionate to single word repetition, they've got logopenic aphasia. And as you can see, the wild things there at the bottom left are all lined up very biddably, apparently going along with that formulation. So let's run with it. So the other extension, the next extension is to say, well, okay, not only are these clinical syndromes, they're clinico-cognitive and anatomical syndromes. And so the party line here goes, if you've got non-fluent aphasia, you've got focal atrophy involving the left inferior frontal gyrus, aka Broca's area, and you've probably got a primary tauopathy, for repeat tauopathy. If you've got semantic variant PPA, it's a very coherent syndrome. You're very likely to have left anterior temporal lobe, very focal selective temporal lobe atrophy, and you've very likely got TDP43 pathology, another type of pathology, and one specific type of that, which is the type C. And if you've got logopenic aphasia, you've probably got Alzheimer's disease and involvement predominantly of your left temporoparietal junctional zone. And the concept that these are network-based diseases is now pretty well established, and the diagram on the right there is showing the networks that are canonically involved, color-coded for the different syndromes. I've skipped over the McPhee radar plots there, but of course they're making the same point, which is that you get particular profiles of both linguistic and extra-linguistic deficits that characterize these syndromes. One visual impression you may be able to get from the back of the room is that the contraction of the radar plot, so a contraction here equals a progressively increasing abnormality. The contraction is most marked for logopenic, which is in fact what we see, that these are the people that tend to have a lot more generally cognitively going on, which is a major theme we'll come back to in that syndrome, which has been picked up by Matt Lamb and Ralph and colleagues. So far, so oversimplified. But of course, it's not like that. And one of the problems, one of the clues that all is not quite well with that formulation is that in most centres that see people with primary progressive aphasia, probably somewhere between 30 to 40% of them, so around a third, do not fall into one of those canonical formulations. And they don't fall into that by virtue of the fact that they've either got a fragmentary syndrome, such as pure progressive anomia, or they've got mixed features of different syndromes. And so they end up being called atypical PPA, which is a nuisance. And the Sendak cartoon that I've put up there is one that's worried me since I was 4 years old. And as you see, you've got to keep your eye on these syndromes at all times. Don't take your eyes off them is the message. And the story only gets more complicated, or the situation only gets worse from here. So the other piece of bad news is that really, despite some superficial analogies that you can draw, and actually despite the fact that remarkably enough, after over 100 years, there really still haven't been really good detailed head-to-head comparisons of vascular and degenerative aphasias. Although I think the Cambridge group have done some of the best work in this line. There's a lot more work to be done in comparing the syndromes. But really, the analogies are not all that close between classical aphasiology and the neurodegenerative aphasias. And I've diagrammed the classical Lichtheim Wernicke model of the language system there at the top, and the sort of fairly obvious, simple-minded ways in which you might get a vascular lesion and a neurodegenerative network-based proteinopathy of the sort that characterises the primary progressive aphasias, the language-led dementias, mapping onto that formulation. And it's not too difficult to see why they might differ. For example, to spell it out, when you've got had a stroke, if you've got a stroke-related aphasia, you've usually had an acute lesion and there's usually some recovery going on. You've essentially eliminated neural elements in the acute event, causing there to be a rerouting of processing. There's likely to be ongoing active plasticity. And the insult, by definition, is usually a primary ischemic one, hemorrhagic one. And if you macro map, what's going on with the deficits and also the damage in the brain, well, that's going to map onto vascular territories, dictated entirely by those, really. And if you look at the situation microscopically, you'll find that there's been necrosis of neuronal microcircuitry. Now, if you compare that situation with the neurodegenerative aphasias, you're dealing by definition with insidious and progressive disorders, graded dysfunction of neural elements, noisy and aberrant processing rather than absent processing, at least initially. Plasticity, although there's some interesting evidence, I think, that it is retained, is overwhelmed. And the lesion is a primary molecular one. The macro mapping here is by large-scale neural networks rather than vascular anatomy. And you actually get remarkably selective lesioning of the microcircuit. And James Rowe's group and others have looked at this, particularly in the behavioural variant frontotemporal dementias, and begun to unpick how this might work. And so with all of these caveats, you think, well, like most things in neurology, we'd better go back to observation and work out sort of how did we sort of get where we are. So some familiar faces here. Now, some of them are fairly obvious, or most of them, I think, are fairly obvious inclusions, but actually I've included them for particular themes, which I'll highlight that they bring out in this work. Also because they've all had some personal resonance for me. And I should say, as it's becoming obvious to you all, I'm sure, that this is very much a situation where the opinions expressed here are my own, so it's personal perspective. But I would just hasten to reassure you that I haven't worked with all of these people. So we start with Arnold Pick, who is very much the progenitor of this field, and he was really his key insight, Bohemian neurologist of the late 19th century. His key insight was that you could get aphasia from a focal cerebral degeneration. Remarkable insight. He even talked about amnestic aphasias and knew that these arose from the anterior temporal lobe. He published classic descriptions of what I think we would now call somatic dementia, the case of August H, interestingly enough, not August D, which was Alzheimer's patient, but August H is usually claimed for somatic dementia, though if you actually look at that case report, there's some quite strange things about that case, I think, that would puzzle a contemporary neurologist. But he also published Anna J, who sounds a lot more like the real deal, and really was the first person to recognise that you get these focal degenerations producing aphasia. And then Henry Head, slightly surprising in inclusion perhaps in the PPA world, but he's there by virtue of what he said about aphasia. And Head's insight, and he was at least 100 years ahead of his time, is that the Lichtheim model just isn't right. I mean, it does not capture the functionality and the complexity of patients with aphasia. And he was an obsessively detailed recorder of what patients said to him and how they experienced their aphasias, and went to great lengths to show that that model was a lot more complicated. And in fact, he also was very much ahead of his time in emphasizing the network-based nature of language disorders. And then after Pick and his generation, really things went into abeyance for over half a century. And even though there obviously were still cases being published, they were largely and somewhat inexplicably ignored by neurologists. Until in 1982, Marcel Mesulin published what was probably the paper in 1982, which more than anything set the field on its present path, which is where he recognized that you could get these selective dementias that produced aphasia without more generalized intellectual deficit, and coined the term primary progressive aphasia, and essentially rediscovered what the German neurologists had originally described, and shaped much of the modern field. Elizabeth Warrington was really the person who gave them their modern cognitive footing, in that in 1975, Elizabeth described in her classic QGEM paper what we now know to be the syndrome of somatic dementia. And her key insight was to recognize that the so-called transcortical sensory aphasia and visual agnosia that these patients had were two halves of the same coin, namely a primary disorder of semantic memory. And this was a remarkable insight, one which really set up the idea that these were system-based disorders. And it's interesting, I think, just to note in passing, that Elizabeth also appeared yesterday as a seminal figure in the world of memory research. So here she is again. Judy Snowden, who coined the term somatic dementia, but is here mainly because I wanted to flag up her contribution, that she was one of the very first people, I think, to really recognise that behavioural change is a major feature of these diseases, and to really start to map out what behavioural phenotypes they might exhibit. Well ahead of the game there. Mary-Lou Gorno-Tempini of the criteria, the current 2011 international consensus criteria, which is more than enough of a contribution for anyone to make. But actually, the reason I wanted to include her is because she's also pioneered the world of international aphasiology and the need for much more global collaboration to try and define these diseases, and a little more about that later. Richard, who before his untimely death really made major contributions to our understanding of the language system, and in particular, for purposes of this talk, taught me how to design a halfway decent functional neuroimaging experiment to study language, and probably has been one of the figures that shaped my own ideas about the language system most strongly. And Murray Grossman, the senior author of the 2011 criteria paper, who sadly now also belongs to the Ages. But he is there particularly because I wanted to flag up his insight that biomarkers are important in these diseases. And, it's not enough to just be meticulous observers of nature. You have to go beyond that to find other objective indices of disease in order to grapple with them and treat them adequately. And in fact, all of these people have in common that they were to some extent prepared to be iconoclasts, but also that they were great observers. And unless it gets lost in the kind of the excitement of all the modern technology and the model making, I want to say now for the first time, and I'll end with the same message, that neuropsychology, clinical observation, is the lifeblood of this field, and without it, there can be no ultimate advances. I sort of offer that as a challenge. So plunging back in. So what are we talking about when we say things don't quite fit? Well, if this plays out, I just wanted to show you an example of a lady who illustrates one of the ways in which this is a bit more complicated than we first might expect.
What's your address?
Although we need some sound.
383.
You got it.
See, I can't talk for Portishead. So it's 3.
What's your address?
383. See, I can't talk for Portishead. So it's 3, and I can't talk.
Okay.
Yeah.
How did you get here today?
Portishead.
All right. Have a look at this picture and tell me what's going on in the picture.
Well, it's
Square
that's
beach scene, Warrington beach scene.
fall over. That's go, and then that's all do.
Okay. What's going on over here? What's going on with these two people?
They were knocking. I feel to put up that one.
Okay. How about this?
Well, that one's just put on a case, you know.
Okay. And how about this chap over here?
Oh, he's fell over.
Yeah. What would you call this thing here?
Don't know.
Okay. How about this down here?
That's see, that's not mine. I can do that, but I can't talk.
Okay. How about this? What are they playing with?
Yeah, that's ball. That's
A ball. It is a ball, isn't
Yes,
it?
yeah.
And what's this boy building? What would you call that?
Well, he built. I love this.
Okay.
Yeah,
How about these things? What are these things up here?
that's birds.
Yeah. Do you know what kind of birds they're going to be?
I don't know.
Okay. So I'm going to show you these pictures.
Yeah.
Tell me what these things are.
Well, that's a break. That's a break. That's a spill. That was aches. That's a whale. That's a bane. See, I can't talk.
So there's an awful lot going on there. So I think if you agree with me, but she's agrammatic, she's severely anomic, she's got some jargon coming out there. We don't show it on the video, but she's got an impaired repetition deficit, more pronounced for phrases than single words. What I've done below there in that table is to represent a summary of another case, not this lady, but another chap who had the same molecular lesion, who illustrates some of the features of how this particular syndrome unites the canonical features of logopenic and non-fluent variant PPA. And you might just say, well, isn't that because she's got severe global aphasia from advancing disease? Except that she was about 2 years in when she presented for that video, and she had pretty well preserved functioning in many areas of her life at that point. And if that isn't enough, then there's the scan, and the scan is one of the most striking that we see in neurology, which really looks like there have been two brains fused together, the right and the left halves, and the whole of that left hemisphere is being taken down by proteinopathy. Largely at this point sparing the right hemisphere. And that goes all the way back into the parietal lobe. And this lady has a progranulin gene mutation. And she actually illustrates something that we've since shown. John Rohr and I wrote up a series of them in neurology, a feature where they unite, a syndrome where they unite these features of agrammatism and logopenic features with this very striking cerebral asymmetry. And one of the many remarkable things about this syndrome is its molecular specificity, because it's very counterintuitive as to how a genetic mutation should produce such strikingly asymmetric brain atrophy, I think. And obviously is an important clue to the mechanism if we only understood it, but it's an active area of research. So that's an extreme phenotype, if you like, illustrating some of the problems with the challenges to the field. But of course, it's not just these unusual cases. All of PPA is atypical. So what I've shown here is a labour of love. Now, this is work led by Chris Hardy, really heroic work, where what Chris has done is to survey the big support groups in this country and in Australia, caregivers reporting on the sequence of symptoms that patients with different syndromes of PPA exhibit. and then sort of marshalling them together into a 6-stage solution for the evolution of these syndromes. And this is an incredibly rich data set, and one which I hope it's out in preprint form. I hope will soon be formally in the public domain for people to digest at leisure, and I hope will be a service to the field, to patients and carers as well. The astonishing richness of these syndromes. So what I've done there is to code the domains of symptoms that are affected. The standard black font is the verbal symptoms, which of course by definition you expect to see leading, which they duly are, up near the top in the sort of stage 1. You can see that it's mainly dominated there by verbal symptoms. But even from the very beginning, you get other domains involved: non-verbal cognition, behaviour. And then as you go down, and as you're coming down here, remember you're going down the more severe disease, the green, which is the physical symptoms, start to dominate. Motor, balance, continence, swallowing problems start to become very prominent features and the main dictates of clinical functionality. And the length of these bars, the histograms, are coding the overall frequency of those symptoms. So you can see that, you know, they're intermingled. It's not as if the verbal symptoms are sort of clearly dominating everything. The other symptoms are also frequently endorsed. And the grey coding here is really indicating the mix of the stages. So you can see that stages sort of blur into one another. So you've got, you know, predominant of white there, stage 1, but, you know, some caregivers are endorsing stage 1 type symptoms even out to stage 3. And so it's a sort of a transition between stages, highly, highly complex. And what this doesn't capture is the dynamics of this. In other words, people are moving through these syndromes at very different rates and not uniformly. So clinically, we recognise people can have apparent periods of rapid progression, of plateauing, and all of that is part of the clinical phenomenology of these diseases. And then there's another theme I wanted to bring out is that we are getting a very, very biased view of these diseases at the moment. Now, what this shows is a PPA literature map of the world. And what I've tried to do there is to colour code the papers that have been produced since the Gorno-Tempini criteria were canonised in 2011, which is to indicate the distribution by languages in which we have had cases being described. So in other words, cases of PPA in languages other than English or across the world languages. And you can see the problem. So for a start, the colour scaling there is on a log scale, because if it was on a linear scale, everything except English would be invisible. So to even make the other papers show up, you have to log scale it. And the other problem with it, the colour coding there is by language families, is that it's not only English, it's dominated by Indo-European languages. And it's even worse than that. So if you look at my native land, you know, English has crushed hundreds of indigenous languages into extinction. These are languages that are, in most cases, not written down, unique, beautiful languages, agglutinative languages, languages that rely a lot more on pragmatism and other features than we see in European languages, all of which we will now never see. So we won't ever know how some of these human languages affect the expression of PPA. But even if you deal with the 20, 30 top most widely spoken world languages, it's a heavily, heavily skewed distribution. So to make any realistic estimate of how PPA presents, we really need to change this situation. And there's an urgent need for much more understanding of languages other than English. And if there's time, we can talk happily about some of the very, very tantalizing early clues as to how phenomena like regularization, semantic failure, etc., might present in languages other than English. So really confronted by all this complexity and these difficulties, so one thing we've tried to do in the brain behavior group is to undercut it a bit by asking, well, what sorts of functions could we look at that might get us closer to the core problem of these diseases, closer to the proteins, if you like, because the protein mappings, although I won't dwell on them for this talk, are no more clear-cut really than the clinical ones. In other words, it's not the case that all logopenic patients have Alzheimer's disease. It just isn't the case. So, you know, if we can't predict the protein, by some means or other, how can we treat people effectively with disease-modifying treatments, which are now on the horizon, very much on the horizon for Alzheimer's disease, for example. So to try to undercut some of the complexity, well, what other functions could we look at that might take us closer to the proteins? One possibility would be non-verbal auditory processing, and in a sense, this is psychophysiology. It's a bridge between cognitive neuropsychology and physiology, which also I think you can sell on the basis that it potentially cuts across linguistics, which of course is a massive issue when you start trying to compare cases in languages beyond English. You've just seen it's a problem. So, how far can we take this? Well, what I've done there is to really put on that slide a summary of about a distillation of about 20 years of work, and I'm asking you to take quite a lot on credit here, which is that the so-called Queen Square tests of auditory cognition, or affectionately known as the Q-stack that we've designed, are designed to map different aspects of nonverbal auditory cognition using simple response procedures that don't rely on things like naming, for example, so they're suitable for use in cognitively impaired aphasic people who also don't load heavily on executive function. And some of the papers in which they've been described are along the bottom there. And you do see coherence. So you can recapitulate to some extent the network architecture of these diseases. So, for example, we argue that logopenic aphasia has a core deficit in the parsing of auditory scenes, but in the specific sense that there's a transcoding of objects that are in those scenes, objects that are behaviourally relevant, and in particular speech phonemes. And so we view a lot of the components of the logopenic aphasia syndrome as a core problem of phonemic transcoding, where essentially the brain's being confronted with a complex mix of objects. It's picking out the most salient for communication, in this case, the phonemes of speech, and then it's having to do something with those objects. So, that might be, for example, a working memory task administered by a neuropsychologist, but it might also be, as we heard yesterday in Ken Norman's talk, extending those onward into episodic memory and into complex behaviour. And when it comes to the non-fluents, we see quite generic problems of auditory pattern analysis, which have got nothing to do with speech. For example, we see it in music, we see it in generic auditory stimuli, timbral, pitch, rhythmic patterns. And in the case of the semantics, particularly interesting one, well, of course, we see problems with environmental sound recognition and also with auditory emotion processing. And these patients get striking auditory hedonic phenotypes, where they have abnormal behavioral and emotional reactions to sounds. And we'll come back to that because I'd argue that there may even be a more generic computational basis for some of this in the semantics. So that's a kind of an overview, but need to really drill down into what we're actually trying to do, to give you some examples of how this might work. So what I'm showing on this slide is work that was led by Chris Hardy, and it's a functional imaging study in which Chris tried to deconstruct speech signals, heard speech signals. So these are patients passively listening to sequences of phonemes in the scanner, about the simplest speech stimulus that you could imagine. And they're not having to do anything other than pay attention to what they're hearing. And what Chris did was to alter the characteristics of these phoneme sequences, very, very elementary acoustic manipulations to do with the tempo, the rate, the regularity in particular. So that's the manipulation of isochrony, the structure of the individual phonemes. And so in this case, we used a technique of what's called spectral inversion, where you literally fit the frequency spectrum of the sound and produce a strange alien sounding, synthetic sounding speech syllable that doesn't sound like natural speech. And for the top level manipulation, the variation of entropy, or the amount of classical information in an engineering sense, information in the phonemes, which here was done in terms of the pitch sequences. So whether or not the pitch of the sequential phonemes was completely random, which is tracked there on the right, bottom right panel, or had a sequence approximating a sine wave contour, which is, if you like, a minimal entropy situation compared to a maximum entropy, maximum disorder, maximum information situation in the completely random sequence. And what they were designed to do was to bring out particular syndromes of primary progressive aphasia using core computational processes. And in fact, they did do that. So what I've shown in the middle panels there is the contrast between patients with particular PPA syndromes and healthy controls who did the same paradigm. And in the case of the non-fluents, the key locus for the contrast between regular and irregular temporal sequences was in the anterior cingulate and supplementary motor area. In the case of the logopenics, it was in the posterior superior temporal cortex. And in the case of the semantics, it was in caudate and cingulate, which is, of course, a non-canonical location for those patients, except that we know from a number of lines of work that the network derangement that's wrought in that syndrome extends far beyond the anterior temporal lobes. But it was only that manipulation that brought out our semantics. And so that's the sort of, if you like, the signal processing type, kind of computational type level. And what we've then done is in other experiments, we've tried to map that onto other types of process. So, for example, also in that experiment, Chris compared the contrast between listening to a sound and listening to silence. So this is in what we call a sparse acquisition protocol. So you can actually switch off the scanner for periods of time to compare what the brain is doing when it's truly listening to silence with when it's listening to a sound stimulus. So there was a difference in our non-fluence between listening to sound of any kind and not listening to sound, which was not there in the controls. And they had reduced activation of primary auditory cortex, which is what that new panel is showing. And what Chris has shown separately is that these patients remarkably have problems with their pure tone audiometry. In other words, they have an audiometric deficit after adjusting for age, which is disproportionate to other patients with dementia, here Alzheimer's disease, as well as healthy controls, and has nothing to do with cochlear pathology, very likely. And then just another example in the case of the logopenics is that this maps onto a problem with this problem with phonological coding maps onto a problem with phoneme discrimination, which I've represented there. So these patients, when you give them the Palper subtest that looks at phoneme discrimination, have a deficit which is not shown, for example, or is disproportionate to that shown by people with Alzheimer's and other syndromes. So what I'm trying to show with these examples is that there's a sense in which these core computational deficits do map onto other kinds of real-world hearing or other types of auditory processing and communication function, although, of course, there's a lot of work to be done with this. And as a sort of a test case, and obviously, as is always the way, I've chosen my best example here, or the one for which I think we've got the most information. And I've tried to link up the work from the brain behaviour group, particularly with work of Matt's group. So I didn't ask his permission, so I hope that's okay, Matt, but just to sort of try and bring this out. So what I'm trying to show here is, how do these wired things mar, right? So how do we get from pathological protein to complex phenotype? And I'm using the example of the semantic variant PPAs, which are probably the most coherent of the PPA syndromes in terms of their pathology and also their clinical phenotype and also their structural brain anatomy. So if you start over at the top left, you start with the protein. So we know that the type C TDP pathology particularly produces long dystrophic neurons in the projection zones of the microcircuit and affects interneuronal connections, right, within that circuit. So what might be a signal for those elements going down? Well, in a spectral DCM study, which we're showing in this panel, Elia Benhu, when she was in the group, led, she showed that they have a selective lesioning of inhibitory connections, both within so intra-areal, within the local circuitry, and also long connections projecting from different parts of the temporal lobe into the frontal lobes. So in other words, they have a macroscopic signature of an interneuronal lesion, which would fit entirely, I would argue, with the type C pathology that most of them will have at post-mortem. And then if you then take that one step forward and say, well, how might that lead to computations? Well, if interneurons are not functioning properly, the flow of information through the circuit is abnormal. And if you pay what Chris showed with his fMRI work, that there's a problem with extracting higher order statistics from sensory information as a core computational problem in semantics, it would follow that an interneuronal lesion of this kind would mess up that sort of statistical inference. And in fact, if you look at fMRI studies, and there's now been an interesting eLife paper from the UCSF group, which has shown much the same thing, you show that the early perceptual networks in the brains of patients with somatic dementia, are increased over healthy controls. So this is not just dead cortex, this is aberrantly activated cortex. And it's almost as if there is a backlog of information which is stuck in early perceptual processing relays and can't get through to the stage at which we normally form coherent semantic representations, which brings us to the work of Matt. This is one of my very favourite papers, the work that he did in PNAS back in 2010, which really is a dramatic illustration of what goes wrong when concept boundaries start to break down in these patients. And it's not just about you can't form that concept. It's also about abnormally promiscuous concepts, templates that match to things that they should not match to. So, for example, things that are crudely cat-like get subsumed into the concept of cat, even though they've got no place to be there. And this can be understood as a sort of an erosion of that precise, sharpened neuronal tuning that happens when your interneurons in the microcircuit collapse. And of course, if you've then got these promiscuous concepts, you start to get over-regularization in day-to-day semantic processing. And one of the most dramatic illustrations from another paper of Matt's, the one led by Sasha Boziat back in 2003, is the four-legged duck. So you end up with a generic representation of an animal rather than the more specific representation of the duck. And of course, that is a visual analog of what is going on in these patients' language. So that's one example, I think, of how the wiring might work. The real leap of faith is to argue that you might be able to find core computational pathophysiological mechanisms for each of these syndromes. And so this figure, which I've reproduced here, is basically laying out a what if it was really like this. In other words, all of that complexity was underpinned by much more generic core computational problems. So I've highlighted the one that I argue holds for semantic, but I think, there's what I would argue there's some evidence that we may see similar core computational lesions with the other syndromes. And I just would mention, by the way, that Thomas Cope's work with James Rowe and Cambridge is starting to show some very interesting evidence for inflexible top-down predictions affecting rule-based encoding in the non-fluent PPA. So it's very much a watch this space. So what we ultimately want to be able to do, of course, is treat these diseases. And what I've done here is to pick up some of the physiological themes that I would argue are going to be important when the great day dawns that we have disease-modifying therapies for PPA, which used to be a neurological pipe dream, but is no longer a pipe dream because we have effective therapies for Alzheimer's disease. So kind of the business end of this is the one highlighted in red here, which hasn't really shown up on the projection, but it's this one, which is the work of Anna Faulkner and colleagues, which is really developing interventions that actually help people communicate better in everyday life. And Anna's insight is that you've got to work at a level of conversations. It's not enough to just work at the level of deficits. You have to involve caregivers, you have to involve real-world communication tasks, which is why she calls this approach better conversations in PPA. And that's an example of the sorts of interventions that are sort of more engaging with real-world function that I would argue we need to develop. But of course, if we're going to implement those, we need to underpin them with biomarkers and with other sort of indices that these interventions are working. And that's where you can plug back in the pathophysiology. And so again, work led by Chris, which is at the top here, has shown that you do indeed have retained cerebral plasticity in these neurodegenerative dementias. You've got it to some extent in all of the PPA syndromes. And the way you can see that indexed here is if you look along, these are people listening to a particular form of degraded speech, sine wave speech. As you go along the sessions, you see that their performance improves in each case, and that's a statistically significant improvement. But you also see that there's quite a heavy modulation, which is, in the case of, for example, the semantics, context dependence, the difference between listening to a highly predictable sequence like spoken numbers versus a less predictable sequence like spoken place names. So the importance of context here bears on that understanding of cerebral plasticity, but nevertheless, cerebral plasticity is there as something that could be exploited. And another facet to this is having quantifiable markers of real-world communication. And here I'd like to highlight work that's just about to appear, led by Jess Jang during her PhD, where she's showing there a series of psychometric functions constructed by from individual patients with PPA, and also their overlaid group means, and the thresholds for understanding of another type of degraded speech, which is noise-decoded speech, which is showing that you can get both meaningful individual psychometric thresholds, but also clear group differences. So, for example, the logopenics have a much elevated threshold for the interpretation, comprehension of this speech stimulus, which is really degrading speech phonemes at the level of spectral detail. So quantifiable markers, which in principle I would just throw out there, it could be applied to any, at least in principle, any human language. So nearing the end of the story, so the last line of Where the Wild Things Are is one of the great lines. It gave me goosebumps when I was 4. It still gives me goosebumps when Max returns home and discovers that he thinks he's been away for a year and a day, but his supper that his mother has left out for him is still hot. And what I wanted to use this slide to say is just how mysterious these illnesses still are. And I can say with no false modesty that I used to think I understood them pretty well when I was a registrar. Now I don't think I understand them at all. And I think that they're just hard. And they continue to surprise me. And this is an example of a very surprising case. This is a chap, Rory Barnes, who's a poet, who has primary progressive apraxia of speech. And we recently published 3 of his poems in Practical Neurology, and this is my favourite. And that's there to remind me to bring us all back to the endlessly inspiring and endlessly surprising individual patients that we see with PPA. And I'd say arguably more than any other area of clinical neurology, or at least cognitive neurology at the moment, PPA must be refreshed and informed by individual observations, because they're going to be the things that tell you, that are counterintuitive, that expose where the problems are with the conventional model making. So summing up, I think it is true to say that the PPAs are unruly beasts, and they're in need of taming. They're protean, they're dynamic, and they're often counterintuitive, and they resist the strictures of classical aphasiology. We definitely do need better readouts of core neural dysfunction, certainly if we're going to start to use use disease-modifying therapies. And the analogy I sometimes use is that if you're trying to use conventional cognitive neuropsychology to actually sort of measure what's going on with PPA, it's a bit like trying to work out what someone's motor problem is by watching them play tennis. You get a lot of information from doing it, but you're a long way from motor neurons. So we need to bridge that gap. And I argue, always bring this back to physiology, that's going to be the key to assaying pathogenic protein effects from phenotypes. And we need better ways of tracking and predicting individual illness, because people vary wildly and their trajectories vary. And even within a trajectory, they're dynamic, and the nature of their deficits vary from time to time. We've already seen the problem with the language distribution of the literature, so we need global collaboration to solve that, a really large-scale collaborations. And any specialist centre can only ever have a snapshot, a potentially misleading one at that, of these diseases. What we really need are, I argue, is uniform protocols where a group of specialist centres are banding together and we assess people systematically, so that particular hobby horses, particular ideas and interests don't kind of then make their way into dogma, that we kind of have a much more representative sampling of the full range of these conditions, because it's quite clear that we're all getting it's a blind man and elephant problem, really. We're all getting only a partial view of these because they're rare diseases. But I would argue that we do have the means to write a happy ending because disease-modifying therapy is on the horizon for Alzheimer's, for neurodegenerative disease. And bespoke and realistic strategies do hold promise. And we have to start laying in the preparation for disease modification now, and that means coming up with dynamic biomarkers, among other things. But I wanted to leave with the message, which I genuinely believe to be true, that ultimately we have to start and end with neuropsychology because the beast is only known in the wild. Okay, so you can't just sit in an armchair and make models. You have to go out and be inspired. You have to have your ideas refreshed, and you also have to know what inconvenient observations are going to refute your pet theories, as has happened often in the world of PPA. And to do that, you need a neuropsychologist. So I'll end with a slide of thanks and acknowledgements. It's been a team effort over the years. All of the patients and families, long suffering and intrepid, I definitely want to call them out. And also my current two senior postdocs, Chris Hardy and Jess Jang, who've led from different generations of the work, have largely led this work. So my special thanks to them, and my thanks to all of you for listening. Thanks.
Thank you very much. Thank you very much, Jason, for an inspiring talk, highlighting the complexities and the difficulties within primary progressive aphasia, which I guess is a theme that we've been pursuing throughout the program, really, is transdiagnostic use and categories and trying to understand the phenotype and the genotype and the mechanisms. And I think this is a really productive way forward. In terms of the, if I may just kick off with a question, one of the things that really struck me, and you highlighted this yourself, which was the hemispheric lateralization of that patient that showed a degenerated left hemisphere, was it? And how do you explain the processes, and would you predict you would find the reverse, and what would be the repercussions of that?
Yeah, so the question is, what is the hemispheric asymmetry of progranulin about? How does that work? I mean, I don't know in detail, but there is our general model of these diseases is that they're molecular nexopathies, which means that you've got a fit between particular protein characteristics and circuit characteristics, which then leads to the phenotype. In the case of the progranulins, we know that they take down long-range intrahemispheric connections, and progranulins implicated in wound healing or in healing more generally, in neuronal repair mechanisms. It's both CNS and systemic effects. And one possibility is that once you get a core insult of some kind that might be happening in the brain, you then get this sort of catastrophic amplification because of the failure of repair. And then because you also involve long-range neural connections, that then rapidly propagates through an entire hemisphere. So that's slightly conjectural, but I mean, we do see, and I think other groups have shown that there's kind of quite striking asymmetry is a hallmark of that syndrome. But actually, I could have shown you other examples where there's sort of striking focality from genetic lesions as well. So it's poorly understood, but I mean, it's an example of where I think the clinical observation is likely to hold a clue to the mechanism.
Thank you. Questions?
I'm Simon Wheeler from Alzheimer's. They're accessible. And I thought, like your earlier registrar self, that I had a pretty good idea of three main types of PPA. I gather there's not. So thanks. That's
at least.
That's right. That's just the so yeah, thanks for saying all that. But one of the main frustrations I have with PPA, the literature, is that it is very, 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 very much focused upon accurate diagnosis of correct type of PPA, characterizing that patients affected, or families affected by it, really over. What does it mean for you long term? Because people say this is a type of dementia, and yet we as distinct clinical syndrome, just like thing, with the occasional kind of sprinkling of behavioural problem. But actually, the majority of this is a progressive terminal disease, and it's very, very good characterization of how PPA turns into more classic dementia. I find it very frustrating. I can't describe that in any accurate sense. That information.
It is confusing, and it's also intersects the sociological phenomenon that it's much more acceptable to say someone has aphasia than dementia, of which we saw with Bruce Willis recently. I mean, but I would just want to leave you all with and I'm sure the neuropsychologists are well ahead of me on this. You know, it is true they are led with aphasia, and often that's what brings people along. It really bothers people, and they can't talk, basically, and they come along. But they've almost always got other things. I mean, apart from possibly the progressive speech apraxia people, where it can be incredibly pure when they first start, most of the others have had something else going on. And, you know, Matt and others have sort of shown that if you start to map this out, I mean, and AJ presented work, it's relevant, you know, you get, it's a kind of a, you know, an iceberg with a kind of a long sort of tail where the aphasia is leading. But often, you know, the language processing is one of the most demanding things that the neural circuit that's under attack can do. So it's no surprise that signals the problem. But the problem is actually potentially much more generic. So dementia is just a catch-all term. So I tell people, you know, when I diagnose them, that they have a language-led dementia. It's an unusual form of dementia. It leads with language, but it does produce other problems. And I set that out right at the beginning, because it usually becomes a management issue for them. And I absolutely agree with you that there's a massive educational lack at the moment, where, you know, there's just virtually no awareness of just, you know, the range of problems that people can have and the special needs that they have, which are not at all well catered for by conventional dementia models. And, you know, we need a lot more research dedicated to these diseases, because they also feed back into Alzheimer's, you know, communication problems in Alzheimer's disease. So, yeah, I think it's an important point and a very difficult discussion to have with people clinically.
More questions? Matt.
Jason, fantastic. So the first one was, it was sort of interesting to me, but maybe not surprising, the semantic dimension of why people want to amenable to telling a full story. And I was sort of thinking about why might that. And is it, can we make more traction there, because it actually, you sort of said it almost in passing, a very sort of coherent, homogeneous, relatively speaking. If we forget that there's behavior variant in patients, which then will expose again. But in the context of PPAs, they're a very coherent group. And so then we seem to make progress. And I'm sort of wondering whether we don't make so much progress because the wild things are much milder than the other two or three types of progressive phases. And then it sort of leads into a discussion, sort of mirroring some of the questions you were asking people earlier about. How do we want to deal with that heterogeneity? So some of the dimensional work that we've been thinking about is one way of trying to go about that, but it could be that we should just be recognizing things as something. So, you know, what you thought about that.
Yeah, I mean, and so the basic question is that the semantic dementia, is it atypically coherent? And I think the short answer is yes. And I think it's a really important test case for understanding how a mapping might work. Not to say that it will actually work with the others, but I suppose my hunch is that we just don't understand the others well enough physiologically. And the other issue, which is a hard thing to say to neuropsychologists, is that there are areas of the sort of clinical phenomenology that you just don't measure with neuropsychology. And I mean, behavior might be one of them, but your complex behaviors. But the other might be something like speech apraxia, which certainly in our standard clinical neuropsychometry, we just don't really get good measures of. So, you know, I think you have to kind of sort of see them in the round, and, you know, it brings up a lot of the themes of this meeting, that you need other ancillary techniques. I haven't had time, I wouldn't have had time to talk at all about the parallel work we do in autonomic recording, which I think is also important, because that's looking at a complementary story, which is much more about physiology, but also cuts across these syndromic categories. And so I think you're right, and it may turn out, and I think it's very striking, isn't it, that you know, in that work that AJ showed, you know, that the semantics stand out as being that, and they obviously are the tractable syndrome. But I suppose my sort of hunch, or my kind of message would be that I'd really like to kind of take that kind of work out into the wider realm, because I don't think it's the kind of a physiological level of analysis being done that widely. Although I think it's definitely starting to gain traction. And I mean, so for example, as you know very well, I mean, the auditory work is, you know, give people the impression it's just us. I mean, so Manon Gruber and Rick Vandenberg in Leuven have sort of done work that it sort of endorses this view. So I think it's a matter of trying to sell people on the story enough that you get others engaged to try and start to look at this and challenge it. But I mean, it would be very interesting to see if others can be quarried out. But at the moment, I mean, I tell your question about kind of how you deal with it. I mean, I tend to like to tell my patients, give them a name, because I think that's quite powerful. I think it helps them, and it sort of helps them in a very practical way, while also acknowledging that, you know, there's a lot of problems with that. Conceptually, a lot of problems with that. Yeah.
Thank you. That was a lovely talk, as expected. I was very interested in the poem that you had for your patient. How impaired was the patient? Because I'm not a poet, but that looks like a really good poem. If there was a big discrepancy, do you think that's maybe because poetry might be more like automatic speech, more of a white hemispheric kind of localization, like kind of doing a counting of the week in favorite patients might be, you know, reserved? What do you think that's the...
So the question is, what's going on with the poem? Isn't it a remarkably good poem? And I would agree. And you know, there's always a bit of a heart sink if someone says, I write, you know, I've done some poems. But I was astonished when he brought in this sheaf of things. So he was a solicitor who had written poetry and for some time, and when he wrote those poems, that three that are produced in that paper and that one that was on the screen, he was using a voice resynthesizing app to communicate. He had a striking speech apraxia, you know, incredibly effortful, largely unintelligible speech, which had evolved over about 3 years. And he was just starting to make spelling errors and binary reversals, which is a thing that we often talk about, where confusing yes and no binary alternatives, and in his case, gestures up and down. So I'd say clues that there is an aphasia emerging there, but very, very striking failure of speech production. So I think that's how he was able to write the poems. But I mean, this idea that there's an inner life that patients have is absolutely true. And I mean, you know, it can be quite a counterintuitive inner life, but it's certainly not the case that all stops just because someone has a primary progressive aphasia. And, you know, there are well-attested examples of semantics who write, and certainly if you go into nonverbal cognition, I mean, you know, the San Francisco group have got lots of examples of enhanced creativity and other examples of people continuing to demonstrate in their life. So I do think you have to kind of listen to that to get an understanding of capacities, because it's not just about, you know, oh, well, what can this person not do anymore? You know, in terms of how they live with the illness, it's at least as important to know what they can still do and what's actually bothering them, or what they're actually, you know, really what they see as important. So yes, it is remarkable. And yes, he reminded me or taught me quite a lot about kind of paying attention to people.
So I'm struck by the fact that in the semantic dementia kind of pipeline, the idea is that there's sort of breakdown in the individual connections of the involvement networks. I was struck by one is that Jane has been showing in healthy participants using MRS that their level of gathering actually is correlates and performance, which is astounding several times. Trying to work out why that might be. So I was struck by your. So naively, I was wondering two things. One is why don't they start having seizures, and also would they be helped if they them together?
That I've had the same thoughts, a naive neurologist. That I think I have referenced that work in the published versions of this. The GABAergic story is incredibly convergent and amazing because, I mean, when Elliot pulled this out, we then went hunting, and lo and behold, it all turned out to be, convergent, which is always a good sign. I mean, I of course I don't know in detail, but I suspect an epileptologist would say it's critically important on the pathways through the temporal lobes, and whether it can access the pathology can access bits of the brain that are very epileptogenic. But having said that, they've got pretty devastated anterior hippocampi. So that is a bit perplexing. And as for the story about GABA, I mean, it'd be very interesting, wouldn't it? It'd be very rational, I think, to actually try and use a GABAergic medication to see what can be done. And I know James has made similar suggestions in the realm of the behaviourals, and it might be that actually this sort of interneuronal lesion is going to turn out to be a much more unifying principle, which is very exciting from a physiological standpoint, I think. I agree.
Fantastic. Any more questions? Yes, Jennifer.
I just want to the syndrome of aphasia and underlying what I was wondering about is what is it else that's going on? Shape.
So the question is why don't the genetic mutations line up? And so, I mean, there's recently been quite a big review of the genetic PPAs that John Rora's group have led, and I mean, it's sort of like, again, it's a kind of a distribution. You find some that would pass muster for being quite, non-fluents or logopenics, and others that clearly don't, and it probably is a continuum. But I think the ultimate kind of answer to that is because they're network-based diseases. And so for a start, there's no reason they would conform at all to vascular sort of models of aphasia. And it's just that, most of the, canonical syndromes that we pull out are probably different networks to the ones that they take down. And in particular, the granulins take down Frost network long connections. So, I mean, they might be the genetic mutation that you might predict from first principles would be the syndrome crossing one. And in fact, atypical logopenics, if they're not Alzheimer's, I think there's a sort of an emerging story now that you have to start to think about granulin, because it's one of the more, in the non-Alzheimer group, the minority of the logopenics, but they're often logopenic plus. And so we wrote up a case recently in Practical Neurology, which was a single case of a chap who had a sort of logopenic, but also a bit of agrammatism, which didn't quite gel, and also quite a lot of early behaviour. So, came in and first time he was in clinic, he embraced and kissed the clinic nurse, which I thought was a bit strange, but the family said, oh, no, that's just him. But he had a progranulin mutation and Alzheimer's biomarkers. So, I think the clue there was in the phenotype that it didn't quite fit. So I don't know in detail, but I suspect it's the nature of the network elements that they affect, which don't fit with our conventional models of the language system.
Okay, thank you so much.